The K2-18 star system is home to a red dwarf star and 2 planets, just 124 light-years from Earth. While K2-18c cozies up close to its star, making it rather inhospitable, its companion, K2-18b, has stolen the spotlight recently. But what makes K2-18b stand out among the 2 planets in the K2-18 star system? What recent develops or discoveries have propelled K2-18b into the spotlight? Let's find out. Thanks to the James Webb Space Telescope, all eyes are on K2-18b. Recent observations of its atmosphere unveiled some intriguing details. Among them, the detection of methane-raised eyebrows, hinting at the tantalizing possibility of life. After all, methane is a potential biosignature. Additionally, the presence of carbon dioxide and the absence of carbon monoxide on K2-18b mirrored characteristics found in Earth's atmosphere. However, the most fascinating discovery was the potential detection of dimethyl sulfide, a toxic gas typically produced by certain algae in Earth's oceans. If confirmed, this finding could indicate the presence of life on another planet, or perhaps suggest a heme planet, also known as a water world. However, it's important not to jump to conclusions just yet, as these interpretations are still subject to further investigation. The question remains, is K2-18b truly a habitable ocean world? Or could alternative explanations account for the data collected by the JWST just as effectively? Based on Webb's density findings, it's plausible that K2-18b hosts a vast ocean and a dense hydrogen atmosphere, potentially resulting in slightly warmer water compared to Earth. This places the exoplanet somewhere between a super-Earth and a sub-Neptune, fitting the profile of an ocean world. The intriguing discovery of methane adds to the excitement, as it typically doesn't persist in atmospheres for long due to solar radiation. The presence of a replenishing source raises the tantalizing question: could this be indirect evidence of extraterrestrial life? However, it's wise not to jump to conclusions just yet. A team of researchers from NASA's Ames Research Center and the University of Washington tackled this question using 2 different sets of models based on the data from the JWST. One set focused on rocky planets with surface oceans, both with and without life, while the other set explored gaseous planets without a solid surface and devoid of life. These models not only predicted the photochemistry of the planets, involving chemical reactions in the atmosphere triggered by photons from their host stars, but also their climates. Their analysis concluded that K2-18b is unlikely to be a lifeless water world because its atmosphere lacks sufficient methane, which contradicts observations made by the JWST. However, the possibility of K2-18b being a water world teeming with microbial life remains intriguing. It's suggested that simple methane-producing organisms could account for the observed methane levels in the planet's atmosphere. Despite this exciting prospect, the team noted that the model representing an uninhabitable, gas-rich exoplanet also fits the JWST data well, and might pose fewer challenges for explanation. The ocean world model faces a significant challenge in explaining both its atmosphere and surface temperature. There's a dilemma between needing a cool surface and the potential for a runaway greenhouse effect, which could render the planet too hot for life. Therefore, the team recommends prioritizing the assessment of planetary temperature before searching for life on exoplanets, ensuring it's not excessively hot to support an ocean. As such, neither model perfectly aligns with all features of K2-18b's spectrum. Future data from JWST could unveil either ammonia, suggesting a gaseous planet, or DMS, strongly indicating a water world teeming with life. What's your take? Will it lean towards a water world or a gas giant? Share your thoughts in the comments below. Meanwhile, let's delve into another extraordinary exoplanet awaiting discovery. There's an exoplanet out there that's been likened to a hellish nightmare by scientists, and for good reason. This infernal world, known as WASP-76b, orbits dangerously close to its star, with temperatures scorching enough to vaporize lead. However, amidst its daunting reputations, astronomers recently observed something unexpected, leading them to use a new descriptor: glorious. Discovered back in 2013, WASP-76b's orbit brings it a mere 48 million kilometers from its parent star. That's much closer than Mercury is to our Sun, painting a picture of extreme heat. Adding to the intensity, its parent star, WASP-76, is a yellow-white main sequence star boasting 1.5 times the mass of our Sun. Imagine if we ever became an advanced interstellar species and decided to journey to WASP-76b, a mere 637 light-years away. What would greet us there? Well, to begin with, this gas giant is tidally locked to its parent star, ensuring that one side is forever bathed in sunlight, while the other remains in eternal darkness. But this isn't your typical sunny day. Temperatures on the day side skyrocket to over 2,400 degrees Celsius, hot enough to vaporize iron. Yes, you heard that right, iron. A metal becomes a gas on this blazing hot hemisphere. But here's where it gets interesting. The extreme heat doesn't just evaporate iron. The planet's ferocious winds carry this iron vapor to the cooler night side, where it condenses into liquid form and falls as rain. That's right, iron rain. This peculiar phenomenon has caught the attention of astronomers, who have observed signs of a rare atmospheric occurrence known as glory. This fascinating phenomenon, akin to a rainbow, showcases vibrant concentric rings of light, manifesting under rare circumstances. Besides Earth, this spectacle has only graced the atmosphere of our neighboring planet, Venus, with its presence. However, witnessing this celestial marvel beyond our solar system has remained elusive due to its stringent prerequisites. To behold such glory, specific conditions must align. Firstly, the atmosphere must hold particles of near-perfect spherical shape, uniformity, and stability, allowing for prolonged observation. Moreover, the planet's nearby star must cast its luminance directly onto the spectacle, while the observer, us in this case, particularly the European Space Agency's characterizing exoplanet satellite, or CHEOPS, must maintain the ideal orientation for observation. If further observations confirm the phenomenon on WASP-76b, it could revolutionize our understanding of this ultra-hot exoplanet. Over 3 years, CHEOPS meticulously observed WASP-76b, conducting nearly 24 observations. Scientists were particularly intrigued by an unusual asymmetry in light observed in the planet's outer regions during its transits across its parent star. This observation revealed a significant decrease in light intensity along WASP-76b's eastern terminator line, separating its night side from its day side. Researchers attributed this change to a distinct directional and reflective phenomenon, termed the glory effect. Despite its subtle nature, scientists are excited about potentially detecting this phenomenon. It's an incredibly faint signal, remarked a scientist from ESA. But why is this discovery significant? What does the glory effect mean for WASP-76b? The presence of this phenomenon in the atmosphere of the ultra-hot Jupiter suggests the existence of clouds composed of perfectly spherical water droplets. These clouds, lasting for at least 3 years or continuously replenished, hint at the stability of WASP-76b's atmosphere despite its extreme conditions. It's an intriguing discovery, hinting at a level of consistency in a place once believed to be in constant turmoil. These revelations also open doors for researchers exploring exoplanets to search for similar optical phenomena, like starlight bouncing off liquid surfaces on distant worlds. Such insights could be pivotal in our quest to uncover signs of life beyond our own solar system. What are your thoughts on this? Feel free to share in the comment section and remember to subscribe to our channel, because this journey belongs to all of us.